Okay, so this my study is a little bit old, and this is about a bike which was being produced in India in 80s and 90s. It actually changed the face of the country because of its fuel efficiency and riding comfort. So this motorcycle was produced by Hero Honda Motors. It was called Hero Honda Motors at that time, and it was a joint venture between Honda Motors of Japan and the Hero Group of India. Uh, Actually, because the motorcycle become very popular, and suddenly there was a warranty problem which came up, and the warranty problem was about front fender getting rusted. And can you see this front fender? This is the front fender, okay, front fender, and this was getting rusted in this area inside. Okay, next slide. So what we did actually, we wanted to solve that customer complaint, and we decided to use the value engineering approach and achieve some cost saving also. We wanted to enhance the value for customer and also promote teamwork. Let's see what we got in the result actually, finally, that I want to present first and then go further with the details of the project. We made the savings in money per bike. This is rupees 49.74, but if you convert it to Canadian dollars, it is $0.8 per bike. Gentlemen, ladies and gentlemen, this looks very small figure because you have seen in the earlier presentations very large figure which are running into millions of dollars, thousands of millions of dollars. But actually, if I want to quote from the book called The Slight Edge by Jeff Olson, we said that small decisions that you make on daily basis, they can compound to big results one day. And this study points to that in that direction. So the recurring saving became 1 million dollars in a year. Percentage saving was 27.6. And in addition to that, it solved the rusting problem completely. The customer complaint were not there. Customers' value increased. Fender performance went up. Material utilization in the Fender went up. And morale of the team also went up. So all the advantages. We followed the basic steps in value engineering. We first made the team. It consisted of the team leader, which was actually me, person from product design, a person from prototype making and approval, a person from product engineering, a person from material purchasing, person from marketing, and a person from service, and person. So now the steps were information phase, function phase, as everybody knows. I don't want to read it. Now let's go into detail. In the information phase, this is the drawing of the fender. Now, if I just pointed out, the main fender is this, and this bracket is like wrapped around in the or wrapped around inside the fender. It has got some pockets which were just for weight reduction, and there was a gap between this fender and the bracket. And what we found in the samples that brought from market in the warranty complaint, that there was mud all around, and there was a lot of mud is stuck here. So when the mud is wet and remains wet for a long time, it creates more and more rust. And there are stains here made of tube, which were like kind of supporting this fender and sort of for reducing vibration. And when we did the material analysis for the panel, this was the blank size, and the weight of the blank was 1.485 kg. The finished weight was only 0.763 kg. That means 51.4 was the material percent was the material utilization, and rest of the material went as scrap. Bracket also did not have any better utilization, only 49.7. This analysis showed to the team that there is a very good potential for reducing cost here and increasing material utilization. Let's see. Now, the detail of the cost for the whole fender. Raw material 32.52. I'm talking of Indian rupees. Labor and overhead 36.41. You can see in Canadian dollars figures. Plating is 22.42. Bracket 86.4. Rivets are 8 numbers. The rivets are made of stainless steel 2.24. And the complete fender is 180.29 or $3. Now, in the function phase, the most important phase of the function phase, if we are good at asking a certain question to ourselves in the team, what is it? What does it do? And what must it do? Now, first question, what is it? So it's a fender. Now, what does it do? What does it do? It stops matter. It has to stop matter. But what must it do? Like it does so many functions: locate parts, increase strength, increase durability, prevent corrosion, enhance aesthetics, minimize vibration. All these functions, if we ask this question, what must it do? Then the answer comes, it must stop the matter. Because the purpose of the fender in the bike is to stop the matter, whatever is coming on the road, that tries to kind of fly off with the running rotating tire. So that could be mud, that could be a stone, that could be any metallic piece, or it could be anything. So it has to stop that. That is the that is the primary objective of having the fender. Rest of the functions, locate parts, increase strength, increase durability, etc., etc. They are not basic because this is not what a fender must do. Must do is stop matter. So only one function is the basic function. The rest are all secondary functions. Now, when we go to the next step, we find out cost of these functions. Finding the cost of the function comes with a little bit of experience. So we kind of discussed in the team, argued with each other on so many points, and found out the cost of each function. Stop matter basic function is 12.66. Locate part 43.29. Increase strength is 8.86. Increase durability 66.6979. Prevent corrosion 21.06. Enhance aesthetics 19.93. And minimize vibration. And the next step is we have to find the worth. Because until unless we find the worth, because worth is the amount of money that should be spent for doing that function. At the minimum money that should be spent for doing this function. So the worth came out to be 2 rupees, 7.4, 3.68 like this. And then if we find the cost to worth ratio, either we take cost to worth ratio or we take cost minus worth, that is the value gap. That's called value gap. Either of the two we can use. So we have used the cost is to worth, and the cost worth ratio comes to 6.33 for stop matter, 5.85 for locate parts, and increased strength 2.4, increased durability 4.58, Prevent corrosion is 17.26 because the worth is too low here. Enhance aesthetics is 3.07 and minimize vibration is 3.08. Now, general guideline in value engineering that I have learned is that if the cost worth ratio is more than 2 or 3, it is a good function for further value study. If the ratio is less than 2, the opportunity for reducing cost is minimal. So we chose three functions basically: stop matter, locate parts, and prevent corrosion. We will put full focus on these functions for reducing cost in the further analysis. Then the team started the creative phase. In the creative phase, the team sat down, like you can see in this photo. This photo is not our team photo. It has been just taken from internet to show the basic thing. But what we do is like we sit down in the team and we set up a few rules for brainstorming. Now, one of the rules is that there is no judgment on any of the idea when we are still in the brainstorming session. Uh, no judgment and no criticism, no laughing on anybody's idea. And we have to welcome each idea royally, as any one of the idea can become a king one of the day. So ideas have to be welcomed royally. Now, when we see here, not many ideas came. These ideas not all of them are not listed here. Only some are listed. But like somebody gave an idea, erect a wall. Now, basically, when we think about the stop matter, we are not thinking Fender. We are thinking stop something, stop matter. So if you erect a wall, it will stop the matter. It is a very wild idea, but it's an idea. It may not work here, it may work somewhere else. So we keep the idea. Corner of the area, cover with a plastic, cover with plywood, apply force, apply suction, like that. So we have done analysis also here. Some idea is wild, some idea is not durable, some is thing not feasible. But cover with a plastic is selected. Likewise, I can't see here what is there. In the function which is locate parts, the idea is like hang with a string, tie with a wire, use adhesive, use structured parts, no fasteners, fasten with bolts, spot weld instead of rivets. So there were so many ideas. Okay, idea selected was fasten with bolts and increase durability. Use a thicker sheet, use aluminum sheet, use plastic fender. Prevent corrosion. Chrome plating is presently used anyway. Zinc plating with bright finish. It doesn't have a adequate corrosion life. It's very short. Plastic fender is a good idea here. Easy to produce but needs to be painted. Acceptability by customer is poor because customers reacted to it and the marketing department reacted to it that plastic is not acceptable in India at that time. So people think it is very weak. It will break. And the other idea was painted steel fender. It is being used as another reference model, but in India, acceptability is poor again. Okay. Okay. Prevent corrosion again is continued. Use anodized aluminum sheet. It's a good idea, but it gets scratches very easily. Use anti-rust chemical treatment on existing fender. Reducibility is very poor and right equipment is not available for mass production. Using stainless steel sheet, good idea. Corrosion life is very good. Aesthetics is also good. Cost may be higher, so it was selected for further studies. We'll see about the cost. Now, all these ideas which were selected have been now detailed out here. So the existing design, as you already know, it is made of 0.8 millimeter sheet, and bracket is 3.2 millimeter thick. Stay is tube, rivets, and finish buffed and nickel chrome plated. And this is the fender. Then second idea was modify the profile, less thickness of sheet, and give ribs for strength. Now, this is the sketch. That's how it looked. Plastic fender looked like this. We made some plastic fenders also for testing purpose. Then the fender made with spot welding. Instead of rivets, it was spot welded here. Okay. Fastened with bolts and screws. So instead of rivets, bolts and screws were fastened so that you can open it out and clean it. Use stainless steel sheet. Yes, stainless steel sheet, same design, but use stainless steel sheet. Anodized aluminum sheet, which is design is same, only the material and the finish is different. And for each of the idea, the cost has been worked out here. We will compare the cost later. Now, when all the ideas have been collected and they have been given it a shape, a usable shape, then we are unable to decide at that moment which idea we should select, because there are so many parameters which guide the final selection. Now, we decided certain criteria. Strength is one criteria, the durability is another, because it has to be durable, it has to last a long time, it should look good aesthetically, it should be easy to implement, because if implementation became difficult, then we will not be able to work it out. Initial cost should also be lower, and ease of production should be good. So what we did, we have these three guidelines: major preference, medium preference, and minor preference. Points 3, 2, and 1. And when we compare each idea from each criteria, A to B and B to C, and like that, we go on giving these points, and we find a score. Total score: strength is getting 7, durability is at 10, aesthetics is 11, ease of implementation 2, initial cost is 1, ease of production is 1. Now, this is for the panel. Similarly, we did the same metrics for the bracket, and we got this kind of a score. And similarly, we did it for the stay A and B, and we got the score like this. Now, this score is a raw score, and we have to see by our judgment that this score is the right score. It is logical. See, strength has to be the best actually. Durability has to be also best. Aesthetic, it should look good. It should be easy to implement. So, like that, if we see in each of these matrices, the score which is available here is almost correct, almost logical. So we took this as the final score, and then after these final score, then we got to check by analysis metrics how to finalize the idea. So this is the analysis metrics. Sorry. Now, in this matrix, what we do is each alternate idea, we list down each alternate idea here, all listed down here, and we put the criteria here, or criteria here, and then multiplying this grading. Excellent is 4, good is 3, fair is 2, and poor is 1. Now, whatever is that idea, whatever is the rank of the idea, by that we multiply, and we come to the final total rating here. So the existing Fender gets a rating of 82. Modify profile, less thick sheet, and used ribs gets 127. Plastic fender gets a rating of 87. Pot welding gets 66. Fasten with bolts and screws gets 73. Stainless steel sheet gets 104. And final idea gets a rating of 75. So if you see, the rating is matched with the idea number 2. Although rating could have been very good for plastic fender, but as I already said, the acceptability was poor and the customers, I mean, like marketing department was our customer. They said that if people think it is weak, they will not accept it. So it got a low rating. Now let us see the complete analysis in one table. The shop matter function cost before VE was 12.66, worth 2 rupees, worth is 2 rupees, and cost after VE is 19.84. Now you will be able to you will be surprised here. Stop matter is the basic function, and cost of that function has increased compared to before. But in value engineering, this is sometimes it is required because we are there to solve a problem, customer complaint, and not just to reduce cost. But at the same time, the cost can be reduced, we welcome it. But here, if the cost has to be increased, let it be. So we increase the cost, and after we cost worth ratio has gone up.
Just a warning, we're coming up to 1 o'clock, so we need to have a couple of minutes for questions.
Okay. Can I just complete it? Just a couple of minutes.
3 minutes is what we have left.
Yeah, okay. We'll do that. So we see that after the cost worth ratio has gone up here, and increased durability also 13.22. So that means this study has given good results. Now we can see this is the fender, how it looks like in the drawing. There is a bracket, other side there is another bracket, and they are connected by a third piece in the center. And there is no gap. So there no body sticks and it doesn't rust. Now you see how it looks. This looks so smart on the bike here. Okay. And the plastic fender idea was also kept in our idea bank, and it was sent it to Honda Motors, and they accepted the idea but did not implement at that time. You see, this is the original C100. This is after the after VE Fender is implemented here, and this is a model which came out a couple of years later. Fortunately, I was the designer of this model. This is called Splendor, and even today, after 20 years, this model is very, very popular in India. So this model has plastic fender. So this idea got implemented in this fender, in this bike. And then prototype model testing was done, pre-production trials, Honda Motors and management approval we got, batch production for producibility, mass production, and then excellent teamwork we got right through. And as I showed you, this is what the final result we got. And customer was happy because the rusting problem got solved, warranty complaints went nil, and customer value went up, fender performance went up, material utilization went up, and team morale went up. Everything is up. Thank you. And now I invite questions.